All right, welcome back. This is our second installment in the How to Use Excel series, and we're going to start talking about plots. In our last one, we talked about how to use different features of Excel, where we were making sure that we could cross-reference things and not have to recalculate things many times. That's one of those things that you'll hear me say, calculate something once. Calculate something once, then reference that calculation is always better in Excel. And we'll see some more examples of that as we go along. But now what we're going to do is we're going to start making some plots. We're going to start plotting data in a way that helps us to look at our data. So let's first start with a very, very simple plot. We're going to talk about hours worked versus money earned. Now, how do we talk about plots? When we talk about a plot and we say this versus that or whatever, I actually said it backwards because I was looking here and then I was looking here. But if I say I made a plot of money earned versus hour worked, the first thing you say is always the y-axis. The second thing you say is always the x-axis. So if I wanted to plot this, I would say I'm plotting money earned versus hours worked, probably not the other way around. Now, Excel has a bunch of plotting features. So there's all sorts of plots in here that you can add and recommended charts and things like that. As a scientist doing scientific work, the only one you will ever use in this class is a scatter chart. The scatter chart plots X and Y data, and that's all we're ever going to do in this chart. We're not going to do pie graphs. We're not going to do bar charts. You know, for an infographic or something, maybe you would, but for our data, it's always going to be a scatter chart. Now, how do I select the data for a scatter chart? Excel tries its best. So, you know, if I've just got my cursor somewhere and I tell it to insert a scatter chart, it may or may not get my data correct. OK, so what people generally do is they'll be like, OK, I want to do all of this data. So let me go ahead and select this data here and plot that. And you can do that. You can select your data and plot it. But it turns out if you do that, and later on you decide to add another row down here because you needed a little more data or a little more information, Excel won't automatically add that to your plot because you only told it to plot this data in this little box. So as with all things in Excel, you always want to do things on a column basis. So if I want to plot all these columns, I've got to make sure that I'm selecting the entire column by clicking on A, not by drawing a little box around. And Excel has some funny things that it does. When you are selecting data, the first box you click, the first column you click, it will use as your x-axis. So if I click A first, and I can shift-click B in order to get B selected, or I can just drag across. I can click from A and drag over to B, or I can click on A and I can control-click on B. The nice thing about control-clicking is I can select non-contiguous columns. Okay. But whatever you select first is your x-axis. Everything else you select after that are going to be separate plots on the y-axis. So if I just want hours worked versus money earned, I'm going to select A first, then B, and then go up here to a scatter chart. Now you'll see there's all sorts of different types of scatter charts. There's ones with dots, dots, and lines, dots, no dots and some lines, other kinds of things. You can't tell the difference between these because our data is fairly linear. And this one that's got curve. What it is it's Excel trying to put in lines to make things look pretty. Now, the point of a data chart in science is not to look pretty. That's not to say you shouldn't look pretty. You should absolutely look pretty. But when you draw a line on a plot, a scientist says that data has been fit to a function. And so if you are not fitting your data to a function, you should not draw a line. So I'm going to tell you that 99% of the time, maybe even 99.9% of the time, when you are plotting stuff in science, you're going to start with the scatter plot. There are exceptions to this, and titration curves and other things where we will actually use those kind of attached line features. But 99% of the time, you're going to use a scatter plot with no lines in them. And then if you want to add lines, you add line fits later. So we're going to go ahead and do this one. So we've got a scatter plot. And now you can see we've got money earned as our chart and all sorts of information here. Now, as scientists, we want our charts to not only be useful, but we want them to be informative. So this chart is not very informative because I'm not really telling myself much. I don't know what the y-axis is. I don't know what the x-axis is. I don't know what this is plotting or what this is talking about or the scenario it is. So one of the first things you're always going to do when you get a chart in Excel is you're going to go through and add all the design elements that you need. When you select the chart, depending on what version of Excel you have, it probably is going to already select the chart tools with formatting. And you're going to go over here to add chart element. The first thing you want to add are axes titles on your x-axis and y-axis. Every single chart you ever hand in to me should have a label on your y-axis and a label on your x-axis. I do not like it, Sam I am, if it does not have those things. So you're going to go to axes titles, primary horizontal. You're going to add that in there, and you're going to put something down here. Here we've got hours worked. Now that's OK because it already has a unit in it, but in general, we don't have the unit as part of our name in science. We might say time, right? So, or here, let's do it that way. Let's even be consistent with what I'm saying. We'll call it time worked. And you always want to have the units in there. And you can put units in parentheses, or if you want to, you can use what's called the unit calculus, I think it's called, where instead of saying time worked parentheses hours, you say time worked divided by hours. I talk about that in some other places, but we're not talking about that too much here. So make sure you've got units on all your axes as well, not just titles. So we've got our primary vertical. Thank goodness in the more recent version of Excel, it primary verticals that axis just like that, and we don't have to change the orientation of it. You used to have to change the orientation of it. OK, so there's our axis title there, and this is going to be money earned in dollars. All right, so now we've at least got a slightly more informative plot, but let's go ahead and change the title. Now for titles, there's all sorts of different philosophies on titles. What I want in your title is I want you to actually tell me what the axes are. So this is going to be money earned versus time worked for a lawyer. L-A-W-Y-E-R. OK, and that tells me a little bit of something about the plot that I'm about to see, and it tells me a situation. Now, in your cases, you're not going to talk about it for a lawyer, but you might say for experiment number 1 in the reaction of OH and CO, or whatever it is. So you might have a 2-line title, and that's OK. So you want to tell me about the axes, and you also want to tell me about the system. So even just looking at that plot without reading a legend, without reading anything else, I know what you're talking about. So again, as an example, you might say concentration versus time for experiment 1, trial 3 in the reaction of OH and CO. That is a very good title. It tells me a lot of information. It can be a little wordy, and sometimes titles can be a little wordy. All right, so continuing on, I've got this pretty good plot now. It looks a little bit better. I want to format this axis a little bit because I don't like all those digits. My axis is taking up a lot of space. I don't really need all those decimals. So I just double-clicked on this guy, and all sorts of axis options come up. Again, it's going to vary depending on the version of Excel that you have. Now, unfortunately, my little personal box is over there in the corner. So what I'm going to do is I'm going to turn myself off momentarily. And down here in the number category, I'm going to expand that one. And you can change all sorts of things about how many decimal places, what kind of number it is, and we'll see that more as we go along. I'm going to take out those decimal spaces, and now it's going to look a little bit better. One thing you can do is sometimes it'll be automatically linked to source. That means if I change my digits here, it'll change my digits on my plot. I actually don't generally like to do that because oftentimes the data I want to see in my columns is not exactly how I want to see it in my plot. And so I will often turn off that feature that says linked to source because I want to be able to control my plot separate from my data because I think it looks better to have no decimals than it does to have those 2 decimals when it's on my chart. All right, so here again, we're looking a little bit better. Some other things that we might want to do is do a line fit. Okay, so let's say we wanted to do a line fit for this guy. One of the things you can do up here is go ahead and add chart element. You go to trend line. The only one we're ever going to use in this class is linear. In fact, chemists work really hard to try to make sure that all of their lines are all of their plots turn out to be lines. It's kind of a funny thing. So we're going to use linear plots in here, but I'm actually going to go down to the more trend line options, because just showing a line on there doesn't tell me a whole lot. It just tells me that there's a line there. And so what I want to do is I want to make sure that I'm not only showing a line on there, but I'm also telling my user something about that line. So I'm going to go to trendline, more trendline options. And I do want linear, right? And you can see it put that dotted linear line in there. And that's fine. And then what I want to do down here is I want to show the equation for that line. And you can see here y is 1500x, which is what we expect. And let's go ahead and display the r squared value. We'll talk about that right now. So there we go. I now have the plot on there and also my r squared value. So I'm going to move that over there so we can see it a little bit better. I highly encourage you, move stuff around on your plots. It's OK to move stuff around on your plots. It's OK to format them and make sure they look really good. I'm a big fan of that. So y equals 1500x, r squared equals 1. We're going to use r squared a lot in this class. It's not the best indicator, but it is an indicator of how linear a line is. R squared equals 1 means it's pretty darn linear. R squared equals 0 means it has no resemblance whatsoever to a line. You're generally going to see r squared values of about 0.9 or higher if your data is at least somewhat linear. And so we're going to use those sometimes to determine, oh, which is the most linear one? It's the one with the r squared closest to 1. All right, so let's go ahead. And I want to make that a little bit bigger. I like to be able to read my legends, so I'm not going to, oops, no, the wrong one. I'm going to go over my home here. And I'm going to click on the font size to make that guy a little bit bigger. Right, so there we go. And I might even put a little white background on that so it clears the things behind it, and maybe even a line, but I don't see my line right here. And that's going to be, I don't know where that is off the top of my head. My brain's not working very well. All right, oh, it's going to be over here and fill in line. There we go. Border, solid line. Oh, so it looks a little nicer, OK? So y equals 1500x. Sometimes it's actually really nice to say that earnings equals 1500 times hours, right? It's a little more descriptive. It's not necessary to do, really, but it is a little bit more descriptive. And so sometimes I will actually change those x and y's to actually say what my variables are, is earnings is 1500 times hours. Oops, I forgot to do that. But you know what? I'm going to go ahead and undo that right now that I think about it, because I want to show you something. There we go. So I'm going to undo that and have my thing just like that. All right. What I want to show you is a couple more things. What happens if I add 9.0 down here? Look, if I add 9.0, Excel automatically updates it. If I add 15, Excel automatically updates my plot. It's really nice. When we select the entire column for our data, then Excel is going to automatically update a lot of things for us as we change it. If I delete this guy, it's going to delete that guy. If I delete it, it's going to delete it. And it's automatically rescaling and doing all these nice things for us. So it's really good to set up Excel correctly. You'll notice if I change my constant up here to be back down to $12 an hour, Excel will update my things. It'll update the ranges. It'll do all that kind of thing. If I happen to be earning $18,000 an hour, Excel will update, and in a day I can earn $140,000. Wouldn't that be great? Just work for a day, you got $140,000, you're done for a year or two. Doesn't work that way, unfortunately, for most of us. So there's some simple things about plots. Okay, we added data live. We were able to subtract data live, which is a nice thing. We did a trend line, and we saw that we can fit this here. Now, one of the things we'll notice maybe in some future data, or I'm just going to really tell you about, is these trend lines often don't give you enough significant figures. Sometimes we need 3 or 4 significant figures on a slope, and Excel doesn't always do that well, especially if we have small slopes. It might just tell me that the slope is 0.001. And I'm going to tell you now, you're never going to get a slope with only 1 significant digit. If you're getting a slope with 1 significant digit, you need to fix it. You need to get a more detailed, more precise slope than that. There are ways of formatting this number in Excel, and you can do that. What I prefer to do is use the slope function, which I'll tell you about in a little while, because the slope function has some really good features to it. All right. Now, let's say we decided that this was our plot. We really liked it. We were happy with it. I'm going to go back and put my white background on there. And we wanted to copy this over to Word. Okay. Why? Because you were writing a report and you have charts as part of the middle of a document in your Word report. So what I want to do is I want to select the plot itself. I don't want to select a part of the plot because it doesn't always work depending on which part of the plot you select. So if I select off the plot and I select outside of somewhere, I select somewhere in the chart area as opposed to, you see how it says chart title there or vertical axis. Chart area. And then I can right click and hit copy. I'm just going to use the keyboard. And I'll copy that over and I'm going to go over to Word. And I'm going to paste that in. So right click paste or choose paste from the menu. And you go like that. And there we go. Our plot looks nice. Now you'll notice one thing in Word is that it actually copies it over as a chart that you can edit. And you're like, oh, wow, it's so convenient. If I decide I want to format things a little bit differently, I can edit the chart. The only problem is that editing that you do in Word doesn't go back to Excel. It doesn't update, oh, Excel, I really want you to now use this font size or this label or whatever. And so if you ever had to change your data and copy your chart back in, then you'd have to redo all that formatting. So I really highly encourage you to make sure you do all your formatting. You paste it into Word, you're like, oh no, I need that to be a different color, or I need that to be a different range. Go back into Excel, make the changes there, and paste it back into Word. Now, sometimes we need to put several different charts on one page, and so we might need to scale them and move them around. And so I'm going to show you, right? We can take this guy, we can make him a little bit bigger by doing like that. We can even make it a little bit taller, so we can change things. And Word does a pretty good job of when you've got a big plot, making it nice and big. What it doesn't do so well is this. I now want a small plot because I want to put several plots on one. And you can see it completely obliterated all the formatting that I did. All that nice work to make things in about the right space and about the right size. All of that work is gone. How do I make sure that the formatting I do in Excel shows up in Word? And the answer comes in how you paste it, not in just making sure you don't make it too small. So I'm going to go ahead and delete this guy. Well, actually, let me leave this guy in here. So I've still got it in my clipboard, and so I'm going to go over here and I'm going to go to paste. And I never remember which of these it is, so I usually go to paste special. I'm sure it's one of those buttons. And what I want to do is, if I'm on Windows, I want to paste it in as a picture enhanced meta file. If you're on a Mac, you're going to go paste special and you're going to paste it in as a PDF. Okay, but I'm going to do that. There we go. Looks pretty darn similar to what I have here. Doesn't look that much different. But the nice thing is, if I scale this down, it scales it the way I would expect it to. Now, it does mean if you're planning on scaling this down that you need to make sure your axes labels are large enough to be able to scale down later. But it does keep all the formatting, all the relative angles and spaces that you had planned for it when you put it in there. Now, you can't edit it, which I actually think is a good thing because it reminds you that you shouldn't be editing it here. You should be editing it in Excel if you want to edit it. Okay. And no matter how big or how small you make it, because it's an enhanced meta file, it will print nicely. It won't be all that like pixelated stuff. If you chose PNG or JPEG or some of those other formats, when you try to make it too big, it'll start looking really kind of ugly. But an enhanced meta file, everything will look pretty no matter what size. You could take this and make it poster size, and it would still look rather pretty. So I encourage you to use that when you are pasting into Word. Enhanced meta file if you're on Windows, PDF if you're on a Mac. So let's go back over to Excel and talk a little bit about some other things that we'd want to do. So I'm going to go ahead and skip to some other data. And here's some time versus concentration data from experiment 1, trial 1, experiment 2, trial 1, experiment 3, trial 1. And, you know, it's not very well labeled because it's time and concentration without units and things like that. I always encourage you, especially your y-axis, right, which is going to be our concentration axis in this case. I always, always, always encourage you to put more descriptive names as your label. So this is going to be the concentration, or even, you don't even have to write out concentration. You can use the square bracket. Concentration of A in molar for trial experiment 1, trial 1. The reason is if we want to combine several of these data points into one chart, by having a good label here, Excel will automatically use that label in the chart, and we don't have to modify it later. So I encourage you to do things like that as you're organizing your data, but I'm not going to finish doing it for all my data here. What I'm going to do is make another plot here. This is what's called an Arrhenius plot that we're going to make. So it's going to practice doing a little bit of formula work. It's going to practice making a plot. And then we're going to see a couple more things about formatting plots. So in an Arrhenius plot, we actually want to plot the natural log of this rate constant k versus 1 over temperature in Kelvin. So this is the data we actually took from some lab or whatever. And now we got to figure out how are we going to plot that as an Arrhenius plot. So I'm going to go over here and I'm going to make some other columns. My rate constant column is going to get cut off there, so let me make that a little bit bigger. I'm going to blow this up so you can see it a little bit better. There we go. And now I still want natural log of this k value, 1 over temperature in Kelvin. It really doesn't matter whether the data you're plotting is in successive columns. I like to plan that way when I can, but remember, whatever column you pick first is your x-axis, every other column after that's your y-axis, and then you can just control-click to do them. But I'm going to go ahead and plan ahead. I'm going to be like, well, let me first calculate my temperature in Kelvin. I'm going to use the formulas. I'm going to say equals this one plus 273. And yes, you could use the 0.15, but since we had whole numbers, I'm going to do that. I'm going to put that down. Oops, I hit the wrong key command there. That was word. All right, I'm going to hit Control D to fill that down, and it did that. Now, since I want my x-axis to be 1 over temperature, my next column is going to be 1 over temperature. So this is 1 over temperature in units of 1 over Kelvin. That's going to be 1 divided by that. Now, I could have just done that calculation in one thing. So I should have just done 1 divided by temperature in Celsius plus 273 in parentheses. But it turns out I like to do things in smaller steps in Excel because it makes it easier to find your errors. You don't have to, but I like to do kind of smaller steps. All right, next thing I want to do is the natural log of k. It's not going to have any units. ln is a function in Excel. It knows how to do natural logs. It knows how to do all sorts of things. If you're not sure how to do a function, you can look it up in Google. But most of the functions that we're ever going to do in this class, it knows how to do. If you want a regular log base 10, you can do log and then optionally supply a base, but it'll be by default 10. If you really want to make it explicit, you can be log 10. But let's go ahead and use the natural log right now. And we're going to take the natural log of that guy. I'm going to go like this and fill it down. And if we're never going to use this data, we don't have to format it, but we could format it, the whole column, in order to make it look a little bit prettier and get maybe a few digits there and a few digits there. Now remember, again, it still stores it internally with all the digits, but externally it's doing it that. OK, so now we're going to take ln of k versus 1 over t, our x-axis first, our y-axis next. Go up here to Insert, Scatter Plot, always the one with dots. And there we go. And you can see this plot looks not quite as pretty as that other one that we made where everything was kind of perfectly nice. And this one's kind of funky looking when we come up because our axis doesn't seem to be in the right spot. We've got all this kind of data shoved off to the right. So we want to fix this. A plot, your data should fill up most of the plot. Not 100%, not from like corner to corner or anything like that, but it really should fill up most of the plot. When you run across data and they're using one corner of the plot, or the only line appears at the bottom, they're trying to hide something. They are not trying to show you the trends in their data. They're trying to make you think their data is linear or make you think your data is nonlinear, and you should always be a little bit suspicious of people who are giving you data where it's only taking up a small portion of the plot. So what I want you to do is make sure your data takes up a good portion of the plot. I want to make sure your x-axis is always down at the bottom of the plot. So when you run across situations like this, we have a little bit of work to do. I'm going to turn myself off again so that you can see all the stuff I'm doing on the right. First thing I want to do is I want to move this x-axis down to the bottom. So I'm going to double click on my vertical axis, and I want to go over here and I want to choose the number options here. So the one that looks like a bar chart helps you change the numbers. And I'm going to go to the axis options here. Now what I want to do is I want to make this axis go all the way down here at the bottom. And so I'm going to take it and my, say, horizontal axis crosses. And again, it looks slightly different depending on your version, but there's usually something like this. And I'm going to take it down to a certain axis value. Now, as I see here, I've got a -8. And so I can just put a -8 down there, and it'll work. If I tab out of that, it now moved my axis down to the bottom, which is what I wanted it to do, which is great. Turns out if I then add some data that's -9, -10, my axis will move back up and be kind of partially in my thing. So what I often do here, you don't have to, but what I often do is just put a very large negative number that I know I'm never going to reach. So I put -1000 there. It'll still always just go to the bottom. Not important, but you can do it that way too. All right, so now I've got my axis at the bottom, right? I also need to add my axis labels here. So let me go ahead and add my axis titles. Primary horizontal was the oops, I still always 1 over temperature and 1 over Kelvin. And then I'm going to add a y-axis label as well. And this is going to be the natural log of k. So there we go. I can see that I've probably got a little bit of formatting work to do on these guys. When you've just got a bunch of repeating decimals, 0.000, 0.000, 0.000, all that's doing is confusing your plot. It's not making it simpler. So I'm going to select that guy. I'm going to go back to my number options down over here, and I want to tell it, oh, I only want that to show 0 decimal places. And now I've got 1, 0, -1, 2. I think that looks a little bit prettier. I also have that problem along my x-axis. My x-axis has two problems. One is I'm only using half the plot on my x-axis. And the other is that there's a lot of numbers down there that make it very difficult to read what's going on. So I'm going to fix those two problems. I'm going to click on my x-axis, and it's going to format my axis options now. It was already up there. If it wasn't, I'd have to double click on it. But here we go. What am I going to do with these numbers? Well, the first thing I want to do is I want to try to make it so that my range is correct. So I'm going to go up here to axis options, and by default, it picks what it thinks is a reasonable range. When I look at it, I don't think it's reasonable because I want my plot to take up the maximum space. Excel shows a high deference to zeros. Like, it wants to start the axis at 0, but it doesn't have to. So I'm going to actually go tell it that Excel, I actually want the minimum of this axis to be somewhere around 0.002. So 0.02, I'm going to do that. And now that looks a lot nicer to me. That looks like, hey, I'm using up most of my things. I'm not trying to hide anything. But I still have a lot of numbers down here, so I'm going to try to make that a little bit prettier. The first thing I'm going to do is see if I can take down 1 decimal point. That definitely makes it a little bit prettier. So I went down from 5 decimal places to 4 decimal places, makes it a little bit prettier. And, that might be good enough. But let's say there's going to be times when that still looks like it's a little squished. And so what I'm going to do is I'm going to make it so there's less things on there by changing the units of my major and minor axes. So instead of making my major axis 0.02, I'm going to make it 0.004. And so I doubled that, and now I have less axes there, and it's a little less crowded. I can read those numbers a lot easier. If I decide I didn't like it, I can just hit reset, and Excel will automatically go back to what it had before, but I'm going to leave it like that. My plot is now a whole lot prettier. I'd still have to add a title to this and probably a line fit with the information and things like that, but it looks a whole lot prettier. So let me go ahead and add that line fit and see what we get. Trendline, more trendline options. I want to display equation and do that. So there we go. There's the equation of my line. Now, let's say I was doing this and I needed that slope somewhere else in Excel. So I was making this chart, and then on another sheet, I needed the slope of the Arrhenius plot, right? And I could put that in here and be like, OK, let me click back over here. Let me memorize that, -6434.9, and write -6344.9, and be like, no, I have to double check that again. Let me look back and be like, OK, that wasn't the plot that I was looking for. And so I go back and fix that. It's kind of tedious to have to do that over and over again, because it's hard to keep track of those numbers. Every time you copy a number, you're introducing a chance for error. So what I always encourage people to do is only calculate things once in Excel, and then have Excel reference your calculation in order to do the work later. So it's really hard, in fact impossible, to get this slope out of that thing right there. So luckily, Excel does include a slope function. And so what I'm going to do is I'm going to put slope there, and I'm going to calculate the slope of my data. Let me move my plot down a little bit so I can see my data. So if you put a formula into Excel and you say equals slope, it's going to tell you the first thing it wants is the known y's. And I'm not sure why they organized it this way, but it's the known y. So I'm going to select column E, and my known x's, I'm going to select column D, and then hit my close parentheses. And there we go. Now it's giving me the slope of minus 6434.929. And if I need to reference that on another sheet, I can. So instead of having to memorize this here, I can now just say equals, because I'm putting in a formula. Anytime you want to reference another cell, you're putting in a formula. And I can actually click back over here to this other sheet, which is really, really nice, and say I want to reference that cell right there. And then when I hit enter, I am now referencing this cell as minus 6434.93. Here's the cool thing. If I ever change my data and my rate constant, instead of being 1.4612, is 1.553, that changed my slope, and that changed my slope here. So they're all referenced all to my data. If I change one thing, it changes it everywhere. So that's really something I want you to try to keep in mind, is calculate once, use many times. So you should never calculate something more than once in Excel. Once you've calculated it, you should have it available to yourself to use in other places. All right, so that's how we can use the slope function, and a little bit about referencing cells across sheets. Very useful things. The next thing we're going to talk about, which is going to be a much shorter video than this one, is a little bit more about that calculate once, use many times. And you'll see some interesting things about how you can name some of your calculations and use them across different sheets. Thanks for listening. Have a good day.